Lesson 29 is simply titled Word Problems, but there's a little more to it than that. We are still working on systems. In fact, we're finishing up what we're talking about with systems right now. But instead of handing you a system, we're going to be giving you a word problem and you have to set up a system. So remember, we have our 3 ways of solving systems. Graphing, probably not going to really use that with word problems. Then we have substitution. That might come into play. I'm going to try to spell it correctly. And then we have elimination. So really, we're going to be using a lot of substitution and especially elimination to solve these word problems involving systems. The big thing to remember is when we're setting up word problems for systems is you got to keep in mind you're basically talking about two things within this problem. So let me give you an example here. The sum, solution to a addition problem, of 2 numbers is 361. The difference, solution to a subtraction problem, between the 2 numbers is 173. What are the 2 numbers? Okay, so identify them. Your first number, call it X. Your second number, call it Y. Now go back to what they're telling us. They're telling us that when we add them together, X plus Y, we get 361. They're also saying when we subtract them, we get 173. So that right there, ladies and gentlemen, is our system. So you have to start by taking the word problem and writing your system, then you can solve it. When I look at this, whenever it's in standard form, I tend to lead towards elimination. Not that we can't solve for a variable, not that we can't graph it, not that we can't use substitution, but I want to see if I can create some opposites. That's what we need in elimination. Also, a lot of times we get confused because we forget that there's like ones, their coefficients are ones there, okay? If I look at this +1 and this -1 here, or you can think of it as plus and -1, there's my opposites. I don't even have to multiply by anything. I could just add these together. 1x plus 1x is 2x's, plus 1x minus 1x, positive 1x, negative 1x. That gives me 0, okay? And that equals, and then you have to add these together, 534, okay? So now we have 2 times x equals 534. I want to know what x is, so I'm going to do the opposite or the inverse of multiplying. I'm going to divide. Whatever we do to one side, we do the other. 2 divided by 2 is 1x equals 267. There's my x value, okay? But remember, it wants to know what are the 2 numbers. If you know one of them, you can figure out the other, and it doesn't matter which equation you use, okay? So just pick one. Okay, say I pick this one. X plus y equals 361. Well, I know what x is. It's 267 plus y equals 361. So then I'm going to subtract 267 from each side. That gives me 0. I'm left with y equals 94. So what are the numbers? 267 and 94. When I add them, I get 361. When I subtract them, I get 173. Okay? So the solving of the system isn't changing, but we're setting up the systems now. A family member has some, look at another example here. A family member has some $5 bills and some $1 bills in her wallet. And altogether, she has 18 bills for a total of $62. How much of each bill does she have? Now, remember what I said. We're going to be talking about like a couple different things here. We're talking about total number of bills and total amount of money. So bills and money. So I've been using X and Y, but I want to show you we don't have to use X and Y. So maybe we say our $5 bills. Maybe try to spell it correctly, right? I'm going to say that's F. And I'm going to say my $1 bills. Oh, why not? Okay, you don't have to use X and Y. It's totally more helpful to use X and Y with graphing, but you don't have to. So let's start. We're talking about the first thing we're talking about is the number of bills. Okay, so we know she has $5 bills and $1 bills, and when we add them together, that's a total of 18 bills. The other thing we're talking about is $62. And this kind of can get us a little bit because we're like, well, wait a minute. What do I put over here? It doesn't seem like we have enough information. It's kind of hidden. And our number of $5 bills here, they're each worth $5. So if we take 5 times F times the number of $5 bills plus our $1 bills, remember, they're worth $1, $1, not a 10 there, times an O, we get 62. So now, probably shouldn't have used O here, sorry. Now we can solve this. Could we graph it? Yes. Could we use substitution by solving for a variable? Yes, we could. Okay. I'm going to choose again to do elimination. Looking for opposites. Okay. Looking for opposites here. So basically, I have 1O and 1O, so I really could just multiply this all by a -1, either one, and put a 1 in here. You don't have to do it this way. You have to create an opposite. So I might choose to multiply the first one by a -1, and you choose to do the second one by a -1. You might choose to do the top one by a -5 to get these canceled out. Totally fine. All right, so I am going to multiply this by -1. -1 times 1f is going to be a -1f plus -1 times -1, 0, or no, oh, again, I shouldn't have used that. That gives me a -1o, put a little sign on there, equals -1 times 18 is -18. Now I just combine it with my other one here. -1f plus 5f is 4f's. This gives me 0. So I don't need this plus sign. Equals, when I combine those together, I believe that's 44. Divide both sides by 4. The number of $5 bills is 11. So we have 11 $5 bills. Now we need to figure out how many $1 bills we have. So grab any of the equations. It does not matter. I'll just take the second one here, right? 5 times f, f is 11. So 5 times 11 plus 0. No, sorry, equals 62. Then we subtract 55 from each side. And I end this problem where I chose a poor variable. Still works, it's just a poor variable. 62 minus 55 is 7 $1 bills. So how many of each bill does she have? 7 and 11. Okay. So again, when we're dealing with setting up word problems, you're going to be talking about two different things in the same problem. So it's important that you identify what those are. Like in this case, the number of bills and the amount of money.